Hello and welcome to today's video, which is about set automation in stop motion. So what exactly do I mean by this? As we all know, in stop motion all the movements have to be created frame by frame, and usually that's done by an animator, and we're talking about organic puppet animation. So the entire process is really creative, and also the end result has a very unique organic feel to it, which I really love. But ever so often it's also necessary to create some very mechanical, precise, inorganic movements. And this can be surprisingly hard to do manually, and also it's just very tedious. And every time I had to move a gear for a couple of hundred times for exact same amount, I was wondering, wouldn't it be cool if we could automate this, like having a little motor move this gear? And yeah, that's exactly what set automation is all about. Obviously, the first things which came to my mind were all the gears and wheels and fans and bellows and pistons which move somewhere in the backgrounds of my scenery. But even outside this very classic mechanical movements, I think many things could benefit from motorization and make the life of animators much easier. For example, very repetitive movements of maybe something moving in the wind periodically, or waves on an ocean, or even moving little light sources around to create interesting shadows, or rotating set pieces, or the camera, of course. And yeah, there are tons of things you could do with this. But for me personally, it always felt that setting up that motion control system and the communication with DragonFrame and the automation and everything would be a bit too much work to actually be of much help. So for most of my movie I animated all the gears and mechanical movements manually. But a couple of months ago I decided it's finally time to buy a proper motion control system, because I needed to create some precise, repeatable camera movements for some of the shots. And as most of these systems are way too expensive for someone like me, I had to do a bit of research, and I came across this company Noxon in Spain, who makes some rather affordable products. And I reached out to them, and they offered to also send me one of their motor controller kits to try out. And so this makes it kind of a sponsored video, but I'm not doing an advertisement here. It's just the system I used for all the examples, but the ideas presented should work for any system out there, I think. So how exactly does this work? First we have this box here, which can control up to 4 stepper motors, which can rotate in very small, precise increments. And then we have this wireless transmitter here, which gets hooked up to DragonFrame, where you can exactly plan out all the movements with this motion control curves, and the commands get sent wirelessly over this box to the controller, which executes them on the motors. And that's basically it. And with a bit of tinkering I was also able to hook up extremely tiny micro stepper motors and even 12-volt light bulbs to the system, which is also extremely useful, I think. So the first things I hooked up were those standard NEMA stepper motors, and that's exactly what this system is intended to drive. Those are some rather big, powerful motors, and it's very easy to use them to create any sort of rotational movements in the set, like gears and wheels and fans. And also linear movements. If you use them to drive a lead spindle, it's very easy to make yourself a little linear drive box. And I made 2 of them, and it's even possible to combine them to have a plane of movement, for example, to create this composite movements. The second thing I wanted to try out were those extremely tiny micro stepper motors. And I think it's a really intriguing idea to use these extremely tiny motors, because they can be hidden basically everywhere in tiny set pieces or even props or characters to drive some little details. So the only problem were those tiny motors use way less power than the big ones, of course, and this drive is not really intended to control them. So I had to use this little contraption here, 2 very powerful 100 ohm resistors in line of the 2 coils. And this basically gets rid of the excess power in terms of heat, and with this it works perfectly fine to also drive the extremely tiny motors, which I think is really nice. And the last thing I wanted to hook up was a 12-volt light bulb. But of course this system is only intended to drive motors, and hooking up a light bulb required a bit more of thinking outside the box, but it's totally possible because stepper motors use a pulse width modulated signal to create the in-between steps between the major steps. And so if you hook one coil output up to the oscilloscope, you can really see what's going on here, how the duty cycle of the signal is changing. And the idea was to use this pulse width modulated signal to control the brightness of the light bulb. So I hooked it up to one coil and used the in-between rotations between the major steps to create the brightness of the bulb. And this worked surprisingly fine, and I also used it on 2 of my shots already. After I got used to the system and was confident about how it behaves and everything, I used it on a first animation for my movie, which was this little gear set from the last update video. The big wheel here gets driven by one of the NEMA steppers, and in order to attach it to the motor, I used one of those squishy Lego wheels and just pressed it against the big wheel, which worked surprisingly fine. The next section of the gear train is also driven by one of the NEMA stepper motors, and in this case I used a geared connection because I was able to find a little plastic wheel in my collection which fitted the brass one quite well. So the third of the 4 available channels is used here to drive one of those micro stepper motors I mentioned, and this one has an additional tiny gearbox attached to it, so its output is much more precise and powerful than the motor can do on its own. And it's used here to drive this vertical gear shaft, which is kind of the output of the entire gear train contraption in the movie. And the last available channel was just used to drive this little light bulb in the set, and it was very comfortable to be able to control its brightness via Dragon Frame and not having to deal with an extra power supply, for example. The 3 motor axes were just configured to be normal moving axes in Dragon Frame, but the light bulb axis is set to be a 3D slider here, and that means I can have different positions, or brightnesses in this case, for different exposures in my scene. Using this technique I end up with 2 exposures for each frame, one with a very bright bulb and one with a very dim one. And by combining those 2 exposures I'm able to create this distinct look I'm looking for. Where the outside of the bulb is really illuminated by the bulb and very shiny, but the inside is still visible with a tiny glowing wire. And that's something I also used on most of my past scenes, but usually I wasn't able to use this when a camera movement was involved, because I had no way of creating those 2 exposures on the fly. So the next set we are currently working on will also make good use of this system, I think. The big desk where the human boss is sitting has an incorporated oven, and this oven has 2 giant bellows which breathe air into the oven all the time, and the human is breathing together with his desk contraption basically, and the 2 make up one giant organism. So that's kind of the idea here. And originally I thought we are just going to move the bellows from below the set with a little screw, But now that we have the two linear drives with the NEMA stepper motors, I think that's a much better solution, and the animator will hopefully thank us for not having to turn tiny screws from below the set for each frame. So yeah, then the animator can really concentrate on the character movements, and I think that's really beneficial here. Just a couple of days ago, we have set up the system for the first time to see if everything works out as intended and how it looks overall. The first two channels of the motor controller are driving the two linear drives, the NEMA steppers here, and the two remaining channels are used to control the brightness of the lamps inside the bellows and the oven. Besides the obvious things I have already did, I think there are a lot more possibilities with this system. One thing, for example, we tried out was using the motion control to move a light source around the set to create this really nice light rays and shadows in the set. Another intriguing idea would be to create a motorized winder rig. So for example, if a puppet is walking and you're only seeing the head, for example, you just need it to wobble up and down, and I think that's something you could automate so the animator can really concentrate on the facial expressions, for example. And another thing I definitely want to use in the future is a blue screen mover. So let me explain. Quite often I have the need to separate a character from its background to insert some fog or smoke or something behind him. And for these occasions it's very useful to have a blue screen there. But in a small set under dim lighting, a blue screen can have a significant effect on the overall lighting, and usually I don't want this. So especially on my metal robot characters, a blue screen is really annoying because it always reflects in the shiny surfaces. So the ideal solution for this case is to take two exposures, one with the blue screen to get the shape and the outline of the character, and one without the blue screen to have the nice color information of the entire lighting in the set and the background. So of course you can move the blue screen for each frame manually, but that's really annoying and difficult to get right without too much flickering. So what I want to make is a little motor which pulls in a blue screen and pulls it out again for each frame, also configured as 3D slider, and then I have two clean exposures, one with the blue screen to get the shape of the character and one without the blue screen to get the perfect color information from the entire character. So I think that's also something which is extremely useful in the future. So after all these nice ideas, let me also quickly mention some drawbacks and limitations of this Noxon system specifically. First of all, the motors can't drive very fast. So it's not possible to traverse the movements you have programmed in real time. Every time you want to see what these curves actually look like, you have to step through the entire sequence frame by frame and let DragonFrame produce one of these previews here. And then it's also not possible to make use of DragonFrame's motion blur capabilities. So in theory it would be possible to drive a motor while the camera is taking the exposure and thus creating some real motion blur, but that controller is just not capable of it. Another drawback are those wireless transmitters here, because every time the distance gets too great or there is some interference, they can lose connection. And if that happens, there's a great risk of losing the position, because if DragonFrame moves the motors, but they don't move because there's no connection, DragonFrame doesn't know, and then it loses its positional information. Because this box doesn't really know where the motors are, it just makes relative increments, and so there's always the risk of messing up your system if you lose a step or the motors move while it's turned off or something like this. So yeah, just keep it in mind when you're doing an animation. Best is to leave the system on and undisturbed for the entire time of the animation, then you should be fine. On many of the shots we did, we also encountered some strange bugs or just weird behavior. I can't pinpoint all of them, but for most of them we found workarounds. But it's very obvious that the software is still in development, and I think it will need a couple more updates until it really runs stable. And in general, I think the capabilities of the system could be greatly improved by a better software. I mean, the hardware obviously is very capable, but it would be really nice to be able to have some more configuring options. For example, how big is the motor I'm attaching to this channel? Is it a big NEMA stepper or a micro stepper? Would be really cool if the system could account for that instead of having to use this tinkery workarounds here. Or the same with lights. It's obviously it's possible to drive a light with this output, but it would be really nice to have it supported by software as well. And another thing I really hope they fix is this blinking light at the bottom, because that is really annoying in stop motion sets, and that's so easy to fix. Please don't have blinking things in stop motion sets. That's just annoying. Anyways, we should keep in mind this is a rather affordable and very easy to use system, and if they keep working on the software, it will get much better in future versions, hopefully. So compared to the much more expensive professional systems, I think you're getting a lot of use out of your money here. And if you're interested to buy one of those yourself, there's a special link down in my video description. Also, if you're ever at a production which might benefit from a motorized rig or other kinds of automated set pieces or props, then yeah, let me say I'm available for commissions, and I think it would be great fun to work on something like this. So I hope you found this rather technical video interesting as well, and if you have any other ideas I didn't mention, then please let me know. Like, what would you use it for in your own stop motion sets? Please let me know in the comment section down below. And yeah, I think that's it for today. Have a good one. Bye bye.